You know, in our digital world, we're swimming in data. But what if I told you the most valuable secrets aren't in the data points themselves, but in the invisible lines connecting them? Today, we're diving into the tech built to map that hidden universe, JanusGraph.
So let's start with a problem you've probably felt before. Think about any social network. You've got users, you've got posts, you've got comments. Now, a traditional database, it's awesome at giving you a list of all your users. Simple. But what if you ask it, hey, find me all the friends of my friends who also liked this one specific post? Suddenly, that neat, tidy database just grinds to a halt. It gets completely tangled up. And that's because this is where those databases really struggle, when the connections, the relationships, become the whole story. Just look at these questions for a second. Asking for friends of friends of friends, that's 3 hops. Forces a normal database to do this painful, slow process of joining tables together over and over and over again. Or how about finding the shortest path from point A to point B? I mean, that's a classic map problem, and most databases just weren't built for that. They see data as stuff you put in boxes, in neat rows and columns. They don't see it for what it really is, a living, breathing, connected network. And this really gets us to the heart of the matter. We can call it the relationship problem. It's that fundamental challenge you hit when you realize the real gold isn't in the individual pieces of data, but in the patterns, the paths, and all those hidden links that tie everything together. To solve that, you need a different kind of tool.
And that tool, you guessed it, is JanusGraph. It's an open-source graph database that was built from day one with a single purpose: to treat relationships like they're the most important thing in the world. This isn't some feature tacked on at the end. It's the entire reason it exists, especially when you're dealing with data on a massive internet-wide scale.
So what is this thing exactly? Well, JanusGraph is an absolute powerhouse. It's designed to handle graphs with billions, with a B of data points, which we call vertices, and all the connections between them, which we call edges. And get this, it doesn't do it on one giant supercomputer. It distributes the work across a whole cluster of machines. That's what we call horizontal scaling, and it means JanusGraph can basically grow as big as you need it to. It's the successor to the legendary TitanDB, so it has a great pedigree, and it's built for the big leagues.
Okay, so how on earth does it manage all that scale? The answer is in its incredibly smart and flexible architecture. This is really the secret sauce. Let's peel back the layers and see how it works. The best way to get your head around this is with an analogy. Think about building a high-performance car. JanusGraph isn't the whole car, nope. JanusGraph is the engine, a ridiculously powerful V12 graph engine that's amazing at processing connections. But an engine needs a car built around it, right? So JanusGraph lets you choose your own chassis, the storage system, and your own GPS, the indexing system that lets you find things fast. This whole design is broken down into 3 clean layers. At the very top, you have the query layer. That's how you talk to the database, using a language called Gremlin. In the middle, you have the core engine. That's JanusGraph itself, doing all the heavy lifting, all the complex graph thinking. And then at the bottom, you've got those pluggable backends, your chassis and your GPS. This separation of powers is the absolute key to everything. It's what makes it so darn flexible. And wow, what choices you have. For storage, you can hook into these battle-tested industrial-strength systems like Cassandra or ScyllaDB, or even Google's Bigtable. These things are built for enormous scale. Then, for indexing, which is basically what gives your graph a super-fast search function, you can use industry giants like Elasticsearch or Solr. The point is, you get to pick the best tools for your specific job. You're not locked in. So, how do you actually drive this thing? You use a query language called Gremlin. And the beautiful thing about Gremlin is how much it reads like plain English. Look at this example. It's like you're just describing a walk through your data. Okay, start with everything, find a person whose name is Alice, and now walk out on all the connections labeled knows. What does that really mean? It's just a computery way of asking, who does Alice know? It's a totally natural way to explore your data. All right, so the technology is really cool, I get it, but so what? Why does any of this matter in the real world? Let's talk about where the rubber meets the road and look at how this tech solves some seriously complex problems.
Okay, here's a huge one. How do banks possibly find sophisticated fraud rings? These criminals are smart. They set up these elaborate networks of accounts and transactions that, if you look at any single piece of it, seems totally normal and legit. This is where the graph just shines. With a single query, you can instantly light up suspicious patterns that are otherwise completely invisible. Things like, hey, wait a second, these 15 different accounts were all accessed from the same disposable device. Or, look at this. Money is being passed around in a big circle and ends up right back where it started. These are the kinds of patterns that are practically impossible for a traditional database to see.
Or let's take another common headache for businesses. Think about yourself. A company might have you in their sales system, their marketing email list, their support ticket database, and your public social media profile. You're scattered all over the place. How do they tie all those pieces together to know that you are, well, you?
Yup, it's a perfect graph problem. You build what's called an identity graph. You can create a central node for the customer, like the hub of a wheel, and then draw connections out to all those scattered profiles. And boom, just like that, you have a true 360-degree view. You can see their entire journey from the first ad they clicked to their most recent support call in a way that those disconnected systems could never show you.
So JanusGraph sounds pretty incredible, right? It seems like it could solve just about any connection-based problem. But does that mean it's always the right tool for the job? Well, not so fast. Like any really powerful tool, it comes with some serious trade-offs you need to understand. This right here is the fundamental choice you're making. On one side, you have JanusGraph, representing total open source scale. You get ultimate control, you can scale it to the moon, it's all yours. But you're the one in charge of building and maintaining it. On the other side, you have managed simplicity. These are services that are much easier to get up and running, but you're playing in their sandbox, by their rules, which can lock you in. It's that classic battle, do-it-yourself power versus push-button convenience.
Let's quickly see how it stacks up against some of the other big names. First column, open source, a big yes for JanusGraph. Scalability, right up there at very high with the best of them. But now, look at that last row. Storage backend. See that word flexible? None of the others offer that. That is JanusGraph's superpower. It's a total game changer, giving you ultimate control.
So it really boils down to this. You pick JanusGraph when your needs are serious. You need it when you're talking about massive scale, billions of connections. You need it when you demand the freedom to choose your own storage and indexing technologies. And you absolutely need it when the idea of being locked into a single vendor's ecosystem is a non-starter. If you're nodding your head to those things, JanusGraph needs to be at the top of your list.
But, and this is a big but, let's be perfectly clear, that power and flexibility has a price tag. And that price is complexity. With JanusGraph, you are the chief engineer. You are responsible for managing not just the graph engine, but also the entire storage cluster and the entire indexing cluster that support it. It's an incredibly powerful setup, but it demands real operational expertise to run. So in the end, it's actually pretty simple. The future of data isn't just about hoarding more of it. It's about understanding the intricate web of connections between it. JanusGraph gives you a powerful open source key to unlock that value, and at a truly breathtaking scale. So the only real question left is, are you ready to find out what's really hidden in your data's connections? Thanks for tuning in.